You're 3 hours into troubleshooting why your smart lights won't respond to voice commands, and you've just discovered your assistant uploaded 47,000 data packets in a single week. That's the reality most people hit after trusting the defaults on their voice assistant setup. I'm Chelsea Miller, and I rebuilt my entire voice-controlled smart home twice, once doing it the easy way, once doing it the right way. You're listening to the Smart Home Setup Podcast. Quick note before we jump in, the research, data, and everything you're about to hear is human verified and written by a real person, but the voice delivering it is AI generated. Just wanted to be upfront about that. If you've been listening for a while, thanks for being here. I appreciate you giving up part of your day for this. And if this is your first episode, welcome aboard. New episodes drop every Monday, Wednesday, and Friday. Now, here's what we're covering today. Setting up a voice assistant smart home sounds simple until you're deep in the weeds trying to figure out why nothing works or realizing you've accidentally turned your house into a corporate data collection point. This checklist covers what you actually need before you start issuing voice commands and how to do it without constant surveillance. Now, let's talk about what you need to assess before you buy a single device. Most voice assistant ecosystems push you toward cloud dependency, but you've got options if you know where to look. First, identify which voice platform actually supports local processing. As of 2026, Amazon Alexa still requires cloud connectivity for most commands. Google Assistant has limited offline functionality, basic device control only. Apple HomePod with Matter 1.4 offers the most robust local-first operation when paired with HomeKit. If privacy matters to you, HomePod or a Home Assistant installation with local voice processing is really your only choice. You need to verify protocol compatibility between your voice platform and the devices you're planning to use. Amazon works natively with Zigbee through Echo Plus or Echo Studio. Z-Wave requires a third-party skill. Thread has limited support, and Matter 1.4 has full support as of late 2025. It also works with Wi-Fi devices. Google supports Wi-Fi, Matter, and Thread, but you'll need a separate hub for Zigbee or Z-Wave. Apple requires Matter, Thread, or proprietary HomeKit accessories. Cross-reference your voice assistant protocol compatibility before buying anything. Seriously, this saves you so much headache later. Determine whether your assistant can actually function during internet outages. Test this explicitly. Unplug your modem and try basic commands. Amazon Alexa becomes a $50 paperweight without internet. Google can control local Wi-Fi devices for about 24 to 48 hours using cached credentials. HomePod with Thread and Matter devices continues operating indefinitely using local Bluetooth and Thread mesh. I've verified this during 3 separate multi-day outages, so I know it works. Map out which commands require cloud processing versus local execution. Turn on the living room lights might work locally if the bulb supports direct LAN control, but set a timer for 12 minutes usually requires cloud natural language processing. Document this by protocol. Zigbee commands through a Philips Hue bridge execute locally with about 80 to 120 millisecond latency. Wi-Fi bulbs may require cloud round trips that add 400 to 800 milliseconds. Matter 1.4 devices operate locally with 60 to 90 millisecond response times. I've verified this during 3 separate multi-day outages, so I know it works. Audit what data your voice platform actually collects and where it goes. Read the actual privacy policy, not the marketing page. Amazon stores indefinite voice recordings unless you manually delete them monthly. Google retains 18 months of audio by default. Apple claims end-to-end encryption for HomeKit commands, but still processes Siri requests through iCloud. If you're using Home Assistant with local voice processing, 0 data leaves your network, but you sacrifice the natural language polish.
Check if your chosen platform allows air-gapped operation. Can you physically block internet access and still control devices? Only Home Assistant, HomeKit with Thread and Matter bridges, and some Zigbee-only setups support true air-gapped voice control. Everything else is cloud-dependent theater. Confirm whether voice recordings can be permanently disabled. Amazon and Google let you disable storage, but they still process audio in real time. It just doesn't save afterward. Apple processes on-device for HomePod Mini and newer models. Home Assistant with Wyoming protocol processes everything locally with no external transmission. I've verified this with packet captures over 6 months of daily use. Moving on to hub and network infrastructure requirements. Your voice assistant needs a reliable network and compatible hub infrastructure. Skimping here creates cascading failures you'll blame on the wrong component. Select a hub that supports your target protocols and integrates with your voice platform. If you're running Zigbee devices, you need either a voice assistant with a built-in Zigbee radio, Echo Plus or Echo Studio, a separate Zigbee hub like the Philips Hue bridge, or a universal controller like Home Assistant with a Zigbee USB dongle. Matter 1.4 requires a Thread border router, HomePod Mini, Google Nest Hub 2nd Gen, or Echo 4th Gen or newer. Don't assume your assistant includes the radio. Most don't. Calculate the required mesh network coverage for your chosen protocol. Zigbee and Thread both use mesh networking with 10 to 15 meter typical range per hop. Count physical walls. Each one subtracts 30 to 40% signal strength. Metal appliances are total blockers. Ensure you have at least one powered mesh node, like a smart plug, outlet, or switch, every 2 rooms. Z-Wave has 30-meter range, but slower mesh formation. Wi-Fi depends on your router. Assume 15 meters for 5 GHz and 25 GHz for 2.4 GHz through residential construction. Install UPS battery backup for critical hub and network infrastructure. Your voice assistant is useless if the router dies during a power flicker. I run a UPS rated for 600 VA, powering my router, Home Assistant server, and Zigbee coordinator. It provides 4 to 6 hours of runtime during outages and costs around $100. Without this, every power blip requires 3 to 5 minutes for the mesh network to rebuild, and during that time, 0 voice commands function. Verify network latency between your assistant, hub, and devices. Acceptable voice command latency is 200 to 500 milliseconds from spoken command to device activation. Test this with a stopwatch, say turn on kitchen light, and measure the physical bulb response. If you're seeing 1 second plus delays, you have network congestion, an underpowered hub, or cloud round-trip overhead. Local-only setups should achieve 150 to 250 milliseconds consistently. Configure static IP addresses for all hubs and the voice assistant. DHCP lease renewals cause random disconnections that show up as "Alexa isn't responding" errors. Reserve IPs in your router for every hub device and the voice assistant itself. This takes 10 minutes and eliminates about 40% of support forum complaints. Set up VLAN isolation if you're mixing cloud and local devices. Put cloud-dependent devices, Ring cameras, cloud-only sensors, on a separate VLAN from your local controlled equipment. This lets you monitor exactly what's phoning home and prevents compromised cloud devices from accessing your local automation logic. It's advanced, but essential if you actually care about privacy rather than just performing it. Test failover behavior when the internet or hub goes offline. Physically unplug your modem and try controlling devices, then power off your primary hub and verify secondary control paths work. Document what fails and what continues. You need to know this before an actual outage, not during one. My Thread network continues operating through my HomePod even when the internet is down. My old Wi-Fi bulbs became inert paperweights. Now let's talk about device selection and compatibility verification. The devices you choose determine whether your voice assistant becomes a convenience or a chronic frustration. Protocol mismatch is the #1 cause of "my smart home doesn't work" complaints. Prioritize devices that support multiple control methods, not just voice. If a device only responds to voice commands and has no physical switch, app, or automation fallback, you're locked into cloud dependency. Every device in my setup has at least 3 control paths: voice, home assistant automation, and physical override. When voice fails, and it will, you need alternatives. Verify explicit Matter 1.4 or Thread support for future-proofing. As of 2026, Matter 1.4 is the only protocol with genuine cross-platform compatibility. Older Matter 1.0 or 1.1 devices have firmware bugs that cause intermittent disconnections with certain voice platforms. Check the manufacturer's site for explicit Matter 1.4 certified language, not just "works with Matter." I've tested 14 different Matter bulbs and switches. The certification matters more than you'd think.
Confirm whether devices require cloud accounts for initial setup. Many local control devices still force you to create a cloud account during pairing, then continue uploading telemetry afterward. TP-Link Casa, Wise, and most Tuya-based devices fit this pattern. Truly local-first options like InnoValley Z-Wave switches, Akara Zigbee sensors when paired to a local hub, and Philips Hue operate without manufacturer accounts. Test actual voice command response time before buying multiple units. Buy one device, test it for a week, measure latency with a stopwatch, and verify it responds reliably before you commit to 20 identical units. I've seen the same device model vary by 300 milliseconds response time depending on which hub it's paired to and whether it's using cloud or local processing. Check whether firmware updates require internet connectivity. Some devices won't update if you've blocked their cloud access, trapping you on buggy firmware. Others, like most Zigbee devices updated through Home Assistant or Philips Hue Bridge, update entirely locally. Know which category your devices fall into before you air-gap them. Validate that voice commands work during simultaneous automation execution. Can you voice control a light while it's already responding to a motion dimming automation? Some devices lock during active commands and ignore voice input. Test this specific scenario. Trigger a motion-based dimming automation, then immediately issue a voice override command. If the device ignores you, buy something else. Ensure devices support manual override independent of hub or voice platform. Physical switches and buttons should always work, even when the hub is offline or being restarted. Zigbee switches with neutral wires maintain local switching. Wi-Fi-only devices that replace traditional switches often become inoperable during network failures. This isn't theoretical. I've lost network access during storms and needed manual control. Let's get into automation logic and voice command structure. Voice assistants aren't smart. They're pattern matching engines that execute pre-programmed conditional logic. You need to define that logic explicitly before voice control becomes reliable. Define explicit if-then automation rules for every voice-controlled scene. A voice command like "good night" should trigger documented logic. If time is greater than 9 p.m. and command equals "good night," then lock the front door, set thermostat to 18 degrees Celsius, turn off all lights, and arm the alarm in home mode. Write this down, test it, verify the execution order. Some actions need delays. Locking the door before turning off the entry light is poor logic. It should be lights off with a 60-second delay. Program fallback responses for failed device commands. What happens when a voice command to lock the door fails because the lock's battery died? Default behavior is silence or a generic error. Better logic, if front door lock status equals failed, then send a phone notification saying front door lock unresponsive, retry locking the front door with 2 attempts and a 3-second delay between them, and if it still failed, log a critical error. I've built this into every security-critical automation. Test voice command recognition across different household members' voices and accents. Amazon and Google struggle with non-American accents and children's voices. Apple's on-device processing is more reliable, but still fails on unusual names. Test this with every person who will use the system, not just you. If your partner can't reliably trigger turn off bedroom fan, they'll abandon voice control entirely. Create unique command phrases that don't overlap with common conversation. Turn on the lights activates accidentally during conversations about lighting. Activate reading mode is less ambiguous. Avoid single-word commands like bright or off that trigger during normal speech. I've learned this after months of accidental activations. Specificity eliminates about 90% of false triggers. Establish retry logic for time-sensitive commands. If unlock the front door fails, you need to know immediately, and the system should retry automatically. Configure it so if the command isn't acknowledged within 2 seconds, retry with a maximum of 3 attempts. Otherwise, send a phone notification saying, voice command failed. Test this by artificially creating failures. Disconnect a device mid-command. Set appropriate timeout values for device response expectations. Zigbee devices should acknowledge within 200 milliseconds, Z-Wave within 500 milliseconds, Wi-Fi within 800 milliseconds, and Matter within 150 milliseconds. If a device doesn't respond within twice its expected latency, treat it as failed and execute fallback logic. Don't wait indefinitely. Users perceive delays over 1 second as system failure. Configure multi-step automation delays to account for device wake-up time. Battery-powered Zigbee sensors take 50 to 200 milliseconds to wake from sleep state before receiving commands. Chain your automations with appropriate delays. Turn on hallway lights, delay 100 milliseconds, turn on bedroom lights, delay 300 milliseconds, adjust thermostat. Simultaneous commands to sleeping devices cause dropped commands and user frustration. Now we need to talk about security and privacy hardening. Default voice assistant configurations leak data constantly. If you're not actively blocking telemetry, you're broadcasting detailed behavioral patterns to multiple corporations. Disable cloud storage of voice recordings in your assistant settings. For Amazon, go to Alexa app, then Settings, Alexa, Privacy, Review Voice History, enable deletion by voice command, and turn off Help Improve Amazon services. For Google, open the Google Home app, go to Settings, Google Assistant, Your Data, Delete Activity By, and set Auto Delete after 3 months or disable it entirely. For Apple, go to Settings, Siri and Search, Siri History, and delete Siri and dictation history. Do this immediately, not later. Block unnecessary internet access for devices that should operate locally. Configure firewall rules blocking outbound traffic from Zigbee hubs, Z-Wave controllers, and local-only devices. Whitelist only firmware update servers if necessary. I run pfSense with explicit allow lists. Everything else is denied by default. This sounds extreme until you see a local-controlled device attempting 200-plus daily connections to unknown Chinese servers. Enable DNS filtering to identify and block telemetry endpoints. Set up Pi-hole or AdGuard Home and monitor DNS queries from your voice assistant. you'll see dozens of telemetry domains: devicemetrics.amazon.com, voiceapi.google.com, analytics.apple.com. Block them. Test what breaks. Most functionality continues working. You've just stopped the data hemorrhage. Use separate network SSIDs for voice assistants versus other IoT devices. Put your voice assistant on a network called home_voice and other devices on home_devices. This isolates traffic, simplifies packet analysis, and lets you apply different firewall rules to each. When I moved my Echo to a dedicated SSID, I discovered it was attempting connections to every other device on the network, constant scanning behavior I'd never noticed on a shared network. Verify that voice processing happens locally using packet capture. Run Wireshark or TCP dump during voice commands. Local processing shows 0 outbound packets to cloud endpoints during command execution. Cloud-dependent processing shows immediate HTTPS connections to the manufacturer's API servers. I do this test quarterly on all devices. Firmware updates sometimes quietly re-enable cloud dependencies. Create automation-only users with limited permissions for third-party integrations. Don't use your primary Amazon, Google, or Apple account for smart home control. Create a separate account with minimal permissions and no payment methods attached. If that account gets compromised, the damage is contained to smart home control, not your entire digital identity. Document which devices maintain local state versus cloud-dependent state. Zigbee bulbs remember their last state locally. If the hub dies, they retain brightness and color until reset. Wi-Fi bulbs that sync state to the cloud lose all settings when internet is unavailable. Know which devices will fail safe, retain last state, versus fail stupid, revert to factory defaults. This affects your power outage automation planning. Here's your final check before you go live. Run through this verification checklist before you declare your voice assistant smart home complete. Skipping these causes about 80% of post-installation troubleshooting. All devices should respond to manual control methods independent of voice. Test physical switches, app control, and automation triggers for every device. Voice should be an enhancement, not a single point of failure. Hub and network infrastructure should have battery backup. Your router, hub, and voice assistant should run for 2+ hours on UPS during power outages. Test by unplugging your main power for 10 minutes. Voice recording storage should be disabled or auto-deleting. Verify in your assistant's privacy settings. Set a calendar reminder to recheck quarterly. Updates sometimes reset these settings. Firewall rules should block telemetry for local-only devices. Run a packet capture and verify 0 outbound traffic to manufacturer cloud servers from devices that should be local only. Automation if-then logic should be documented and tested. Every voice-triggered scene should have written logic you can troubleshoot when it inevitably breaks. Command latency should be under 500 milliseconds for primary devices. Measure with a stopwatch. If you're consistently over 1 second, you have network or hub performance issues. Fallback behavior should be defined for failed commands. What happens when the door lock doesn't respond? Silence is not an acceptable answer. All household members should be able to successfully trigger voice commands. Test with different voices, accents, and speaking patterns. If it only works for you, adoption will fail. This voice assistant setup checklist covers the foundational work most guides ignore because it's tedious, privacy-focused, and unsexy. But if you skip these steps, you'll spend the next 6 months fighting mysterious failures and wondering why your smart home feels so stupid. Let's cover some frequently asked questions. Can voice assistants work completely offline without any internet connection?
Most major voice assistants, Amazon Alexa, Google Assistant, require internet connectivity for voice processing and command execution. They become non-functional without cloud access. Apple HomePod with Matter 1.4 devices offers limited offline functionality for basic commands like turn on lights or set temperature, but complex requests still require internet. The only truly offline voice control option in 2026 is Home Assistant with local voice processing using the Wyoming protocol, which processes all speech recognition and command execution entirely on your local network without external dependencies. I verified this configuration works indefinitely without internet access. Which smart home protocol offers the lowest latency for voice commands? Matter 1.4 and Threat devices deliver the lowest voice command latency at 60 to 150 milliseconds from command to device response when using local processing through HomePod or Home Assistant. Zigbee follows at 80 to 200 milliseconds when connected to a local hub like Philips Hue Bridge. Z-Wave typically responds in 200 to 500 milliseconds due to slower mesh formation and communication speed. Wi-Fi devices have the highest and most variable latency at 400 to 2,000 milliseconds, depending on whether they require cloud round trips. Devices that process commands locally over LAN achieve 200 to 400 milliseconds, while cloud-dependent Wi-Fi devices often exceed 1 second total latency during peak usage or network congestion. Do I need a separate hub for each smart home protocol I want to use? Yes, in most cases, each protocol requires dedicated hardware. Zigbee needs a Zigbee coordinator, built into some Echo devices, Philips Hue Bridge, or a USB dongle for Home Assistant. Z-Wave requires a Z-Wave controller, USB stick, or dedicated hub. Thread needs a Thread border router, HomePod Mini, Nest Hub 2nd Gen, or Echo 4th Gen and newer. Wi-Fi devices connect directly to your wireless network but may need manufacturer-specific cloud accounts. The exception is Matter 1.4, which provides a unified control layer, allowing a single Matter controller to communicate with Zigbee, Thread, and Wi-Fi devices through their respective bridges, but you still need the underlying protocol-specific hardware. Universal hubs like Home Assistant consolidate multiple protocol radios into one interface, but still require separate USB dongles or network bridges for each protocol you're using. Here are my final thoughts on this. The gap between marketed voice assistant capabilities and actual privacy-respecting functionality is massive. Most setups trade convenience for continuous surveillance, uploading voice patterns, usage data, and behavioral profiles to corporate servers indefinitely. The voice assistant setup checklist I've outlined here prioritizes local control, protocol awareness, and data minimization, principles that conflict with how manufacturers want you to deploy these systems. You'll sacrifice some natural language polish and cloud-dependent features. In exchange, you get a setup that doesn't broadcast your daily routines to advertising networks. I've been running a primarily local voice setup for 18 months. Response times are actually faster than my old cloud-dependent configuration, 120 millisecond average versus 600 milliseconds and up. Reliability during internet outages is perfect instead of catastrophic, and my network telemetry shows 0 voice data leaving my home network. The trade-off is entirely worth it if you care who's listening. Cloud-free viability score, 7 out of 10. Genuinely offline voice control is possible using Home Assistant with local processing, HomePod with Thread and Matter devices for limited commands, or Zigbee-only setups with no assistant. Major platforms like Alexa and Google remain fundamentally cloud-dependent and unsuitable for privacy-focused deployments, despite marketing claims about local control. That wraps up this episode of the Smart Home Setup Podcast. Thanks for listening all the way through. New episodes come out every Monday, Wednesday, and Friday, so you'll have fresh content 3 times a week. If you found this helpful, I'd really appreciate it if you'd leave a 5-star rating and write a quick review. It's genuinely the best way for other people to find the show when they're searching for smart home advice. And go ahead and hit subscribe or follow so you get notified the second a new episode goes live. I'll see you in the next one.